So before we start, I just want to mention that we will have the next lecture on Monday. We will have the presentations, right? So it's the second assignment, and we will have Augusto, Conrado, Rocky, Eliezer, Flávio, and Frederico presenting the research. It's 15 minutes presentation. You can present either your research proposal or the results. So the content in the first assignment or in the third assignment, up to you, whichever you feel more comfortable. If you, for some reason, cannot uh, do this date, please let me know. So then I try to rearrange. So this is the 8th of February, 4 o'clock. So the time of the lecture. I send you by email the hour, the expected time for you to present. And then on Wednesday, so next week, Wednesday, is going to be Lara, Marcos, Patrick, Paulo, and Renan. Please let me know if you have any questions. On the first lecture slides, I have the criteria that I will use to mark your presentations. So it would be good to have a look at them, and in order to structure your presentations well and get a very good mark. Right, Natalia, so you can start the lecture. I guess there will be several steps, like you'll have to install GAMS, right?
Yes. So it's not actually like how you said, a lecture. So we're going to make tutorials. So did not prepare like slides as Julian already did in the last class. But I wanted to help to know if you already installed the Anaconda, so we can continue to make the installation steps. So you can share with me. So the next step is to install GAMS. So first, I would like to know if you have the Anaconda. Everybody has?
I do.
Yes. Yes, Conrado. I know some of my classmates from Leta, they have Anaconda, so I know they have. Oh, okay, perfect. So you didn't have any problem, everything's fine? Okay. So the next step is to install GAMS. So I'm going to follow the tutorial here on the message documentation. So it's very easy to follow. And if you're not going to able to do this right now, you can do later. So you can just check what we are doing here. So to install GAMS, the first step, you have to go in the GAMS website and choose your platform. I'm using Windows, so I download from here. So if you don't have, please start downloading right now. And when you're doing that, please, you have to make sure when during the installation, you have to make sure to use the advanced installation mode when the software asks to. And then you have to add GAMS directory to path environment variable. I don't know if because I already have installed, I don't know if it's gonna be, I already have installed. So I'll have to wait for some minutes before you have that. But I'm gonna show here the next steps. So this is really important to have this path because in the sequence, all the documents from message are going to be in this path, in this location. And this helps to make the model to work better. I don't know why, but it's worked better when all these documentations are in the same place. so are installing GAMS. It would like better if you have like a razor hand. For me, I think it's easier than to write in the. Okay. So you are all set up on GAMS? Okay. Can I keep going? Not yet. Okay. I wait. This documentation, while I wait, I'm going to just talk about a little bit for this documentation from IASA. It's really helpful. It's very easy-friendly because you can see, I'm going to show here, all these parameters definition. For somebody that is already familiar with Python, it's very easy to use because you can see the parameter and the functions you can use in the what you can change inside the parameter and what is default, what can be need to be done or not. So it's very very complete, all this documentation.
Hi, Natalia.
Hi.
So you also have problems with cats going through?
Oh, yeah.
Just a question again. Should I use advanced installation mode or not? I don't remember what you said.
Yes, you should. Here.
All right.
You should check the box labeled Use Advanced Installation Mode.
Okay.
And add GAMS directory to path environment variable on the advanced options page.
All right. Thank you.
Julian, you're there? Okay. Because I'm a little confused here because they say that you need to have a license for GAMS, but then you can download. I was a little bit confused with this. Ah, okay. Ah, okay, okay. Thank you. I'm gonna put here the link. GAMS Studio or GAMS ID. I don't know where are you because it's here, Augusto. Let me put the. Doesn't have the. I hope it's the studio.
Hi, Natalia.
Hi.
But in installation, there's a step with two options: use GAN Studio or use GAN IDE.
Julian, can you help me because I don't remember this. I think I don't remember this step, and it doesn't say nothing here. Let me see.
Okay, thank you.
Oh, Conrado is finished. Nice. More, somebody else is finished too. This is the more difficult part. The other parts are going to be easier. Anaconda, it's the worst. So, okay, so I'm gonna keep going, and if you need anything, please say, Natalie, please. Okay. So this is optional, the graphivis, and we're not going to do this right now. We are going to do this later. First, we're going to install the message. So to do so, please follow with me. I think it's easier than keep reading this. So open your Anaconda. And launch your prompt. Everybody has your Anaconda open. I know you can be. So you just can copy these instructions. It's easier. You don't need to put the conda if you are using the Anaconda prompt. Just config, preamp. Oh, let me see if we need to put conda. We didn't need to before. Oh no, I need to put conda. Okay. Now you're going to create a message environment. So copy this, conda, create, name message environment, or you can put the name you want. I put just message on my computer, conda, create. And then I'm not going to create because I already have it, but you can please keep forward. And then after this, you're going to activate the message environment. So I'm gonna.
Natalia?
Yes.
I have a question. This lecture will be recorded?
I think, Julian, are you recording? Okay.
Okay, thank you. I cannot follow all the steps because the notebook is very slow here, but I will set the class and try later here.
Yeah, because we are going to run the tutorials later, Hannah. So it's better for you to.
I will try.
Okay. So it's very easy. You just have to, in the sequence that is here, you just copy and put in your prompt. It's very, very easy. So everybody here is in this step. It's hard for me to see, so I don't know if I'm going too fast or too slow. I don't know your computers and your internet, but I'm trying to keep following. Okay, so now we are going to activate the environment that we create, and then we are going to install the message. So we are going to activate message, or the name you put in your environment. Now you're going to install the message. You can do the same thing, like copying here and pasting on your prompt. I already have, so I'm not going to do it again. Here you can see that after activating everything that I'm doing from now, it's on my message environment. So please tell me when it's finished. Still working. Okay, thank you. There is another way to do this, but I prefer to follow the tutorial. You can do everything using just the Anaconda, but here it's easier to. Can I go? So here it's saying that after you install the message, all the tutorials are going to be installed together. So we don't have to install the tutorials. We just have to access them in the message documents. So you finish? How you going? Still running? Okay, so we are in user Natalia, but now we are going to access the documents from message that we just installed. So you're going to put here cd/path/2/tutorial. We are going to access the tutorials from message. I'm going to copy this and put in our chat, so you can just copy and paste. This is to be equal for everyone. So now we are here. O sistema não pode comprar. I made something. Okay, I have to start from scratch. So I cannot be in the message environment. I have to do this before. So cd path to tutorial. Why is not here? I just did that. Let me see what I did. Well, I just did that before I start the class. I don't know what is happening. It's something that happens when we are teaching. Stop working. You did that? What I'm saying? You could access the path, or it's just not working for me?
Here is saying the path cannot be found.
Let me check what is happening, because here Okay, this is the way they teach here, but has another way. Oh, here it's path to tutorials. Here is for the other files, but they have this for the tutorials. But has another way that you can do that. That's very easier too. That is from the GitHub repository. But to do that, you have to download the GitHub desktop. If you have the Git, but we already have that installed. So let's try again. So sorry, I don't know what is happening. I just did that. It's here. I'm gonna show you. See path to tutorials, and here in the YASA message we have the tutorial, and here we're going to access them with Jupyter. Let me try again. Somebody can help me. No. Okay. Message.
The path was not right correctly.
Yeah. It's the path to somebody already did that. It's worked. It's not. It's wrong for. I don't know. It's so frustrating that.
I don't know why, but I don't have such folder in my computer. Path.
After installed, it should be like default
Neither do
after
I.
installing message. No, you don't. You don't.
No.
But the message worked the installation.
Yes.
Yes.
Yes. Okay. So let me see here. Let me see if I lost something here in the. Please,
Maybe
Julia.
we need to download the path folder. I don't know.
No. Let me see. Copy games model files for reading. No. You can. You can check the installation if it was successful. Como install message. Okay, so I really don't know what is happening. Sorry, I just did that before I tested. So, and here doesn't say how to do that. You know how to, you have to install the path, Augusto?
No, I don't know.
No? Oh, I don't remember to do that. I don't know for sure. So let's do the GitHub option. I think it's easier. So you have to download the GitHub for desktop. It's very fast and it's easier too. So you have to download the GitHub. You can download. And then we are going to access the message GitHub documentation from it. It's very easy, and then you can use later for all the other Python coding that you're going to need. So you can use later. So after you have the GitHub, you just have to copy, go to the GitHub, the message page on GitHub, and then you just have to copy the page, open your GitHub desktop, you don't need to create an account. You just can copy the repository. You can clone repository. You just put here in the URL, copy the message, and then you clone it. I already have, so I don't know what's going to do. Okay. And then you have to clone, and all the documents are going to be installed in your computer. And then you can access from Anaconda.
Natalia,
Yes.
I just run this command. And now the cd slash path works.
So I have to be in the message environment, or no? I have to be.
Yes.
Yes. Okay. So let's do what Augusto said. Okay. It's easier to do. Okay. So now you have access to all the tutorials from GitHub. That's it, Augusto?
Yeah.
Okay. So now we are going to open the Jupyter notebook.
No, I think
Yes.
I think.
Sorry, I didn't understand your question, Julian. Oh no, from CD, from this command to access the tutorials, I couldn't. So yes, we are going to use now the documentation from GitHub. You are Augusto send it. Yes, you just have to copy these and put in your prompt, and then. Oh yes. To access, you just have to put this command to access the path to tutorial, which is being installed with when you install the message. Here, path to tutorials. So let me try again, because I did from here CMD, but okay, so it's. Anaconda here. Okay. No, I don't know. I don't know. Oh, CD space. Okay. No. Mm, 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 mm. Oh yes, it worked. It was just an X. Sorry. I can't believe it. Ah, okay. Okay. So guys, this was live action on Python. So you can see that just one word can be very important. So okay, now you have put the Jupyter notebook and we should start. From here it's gonna open the Jupyter. And it's gonna open directly in all the documentation from message. So
For me, it opened the Jupyter notebook, but it was not in the Messenger folder. I can find it.
no, but for me, it worked without the space here. Look. Yes. For me, it was just missing the X, the S. So if you couldn't find this, you still can use the message from GitHub or cloning here or using the command Augusto sent to us. So you have three options to access the tutorials. So yes, good. And if you have, okay, Hannah did it. So now is the time for us to fix it. Any problems, we are here to help. That's why we are doing this together. This is not an easy task. Okay. Yes. Conrado, Lara.
I was not able to make it work.
Even
could
from
you paste
GitHub?
again? Yes, because it asks for an account, so I have to create an account.
Ah, okay.
Could you paste the text from Augusto?
Yes, yes.
I accidentally leave the chat. Thanks.
Augusto put it. And if you do from Augusto, I'm gonna show how to access. So let me put here, activate message. And then I'm going open my Jupyter from here, not from the. If you're doing as Conrado is doing, after you download you clone, you go to documents, And then over there is going to be GitHub somewhere. GitHub here, GitHub. And then over there is going to be the message documentation you just installed. And here is the tutorial. So there's just two ways. You can access from the CD path to tutorials, or you can download from GitHub and access from the documents, GitHub message tutorial. You have these two ways. So everybody is set up? Okay. We are going to start. So here in message documentation, they explain everything. Is very easy. It's very understandable. Oh, here it was the code. Okay, sorry. Let me see. Also, they say to start the tutorials from the base model of the Austria, because here they prepare the model from the beginning with all the necessary parameters. So we're going to start from this base model. So wherever you could access the tutorial, please go to the Austrian energy, and then go to the Austria. This is the first one, and you have to start with this, and then we are going to run some other scenarios. Here is some installation, but here is it's important for us to read. So we'll build a model for the Austrian energy system from scratch, and the process will involve defining our model's time horizon and spatial extent, and then populating the model with data associated with model parameters. Once we have a baseline model, we will then move to investigating policy scenarios. We will be populating different kinds of parameters, including economic parameters, the interstate and the demand, technology parameters, which include engineering parameters, input, output, technical lifetime, capacity factor, techno-economic parameters, which involve the investment cost, fixed cost, and variable cost, and the dynamic behavior parameters, which include some bound activity up, bound new capacity up, is to add dynamic to the model, and then emissions factor. As I showed you before, all the parameters are here, and we can access the definition of each one of them, what includes in them, what we can include, exclude, what you have to put to run. And then the final product, at the completion of this exercise, we will have developed an energy model. It's comprised of the below reference energy system. So this is how message works. Julian presented this in the last class. So we have the resources, and then we have the technology to transform these resources in energy. And then all this energy is directly linked to the energy services. So that's how it's gonna work. So in the first time in any model you're going to use, you have to set up the required packets. So in this case, we have to import iter tools, import pandas, import matplotlib. We import the message and the IX framework, and also these other packets. Then we launch the IX modeling platform using local default database. The easier form to run is just to use the commands Shift and Enter. Or you can just click here in Run to run each. No, made max. Okay. Let me try. I don't know what's happening. Let me try from here because I didn't run anything before. Okay. Let me see if I'm the wrong Jupyter. Okay, now I'm fine. And then we run the IX modeling. And in this line, we are just naming the model, the scenario, and so our model is going to be called Astronaut Energy Model, and the scenario is going to be the baseline. And we are doing developing a installed energy system model for illustration and testing. In this scenario, I'm going to link this information to the GAMS. Here they explained here with more detail. Parameters written in bold are auxiliary parameters that are either generated automatically when exporting to the GDX, which is the GAMS. So this is really important to be very set up. So now, okay. I run again. Okay. So everybody's following? Is everything fine? Raise your hand. Okay, thank you, Hannah. Fake and Giovanni. Let's see what's happening here. Okay. Let me try again. So I'm going to start again. So I'm going to close it. That's something I learned from using message. After you open, it's better you close before start again. So it's not going to work. So I'm going to start again to see if I missed something. Oh, okay, so now work it. So here we are going to work with the time and spatial detail. The model includes the time periods from 2010, 2020, 2030, and 2040. We are going to work here with the 2010, 2041. For this step, it's going to be 10 years. And we are at the Arizona to our scenario. And the country is Austria. So let's run. Then the model structure. We are going to add the commodity, which we're including here the electricity, light, and other electricity. And then you're going to set the level, which are the level of these commodities, which are secondary and final use. And we're going to put the mode, which is standard. And then we are going to add the economic parameters, the definition of the socioeconomic discount rate. So we're going to add PAR, the interstate, the horizon, and the value is going to be 0.005. And the fundamental premise of the model is to satisfy demand for energy services. To first order demands or services, for example, electricity, track with economic productivity, the GDP, and therefore, as a single example, we define both a GDP profile and a correlation factor between the GDP growth and demand, called beta. Beta will then be used to obtain a simplistic demand profile. So the GDP series is here. The beta is 0.7, and the demand is going to be the GDP multiplied by the beta. So for each country is different. For Brazil, probably is not going to be the same. So, and you have to, when you're making your model, you have to make sure these data are very, how can I say, real, like from important sources. So here we have our technologies, the plants, the coal power plant, gas power plant, oil power plant, the biopower plant, hydropower plant, wind power plant, and solar photovoltaic power plant. Then we have secondary energy technologies, which are our plants plus the import, if your country needs to import some energy. And the final energy is equal to the electricity grid. You're adding lights, bulb, and CFL, and useful energy tax are the lights plus appliances. Then we have technologies that we are going to add, secondary, final energy, and useful energy, and then add the scenario to the scenario technology. Here is very important too, to have this data really straight, which is the demand per year. They took from the IEA statistics. Yeah, that's a really good source. And then we are going to set up the demand. So the node is the country, the commodity is the electricity, the level useful, the year is the horizon that we already defined. And then we're going to demand to include the demand per year and the light demand. And then you're going to set up this demand. And we have our engineering parameters. These are the vintage years. This is the vintage years, Julian, is the years that the plants are constructed or before. And then we have yes, perfect. So that's really important to set these parameters too. And then here, I'm not sure if it's needed to go through all these parameters, because it's very similar to this. It's just because we have to set up these parameters to be in the same page, as we can tell, the country, the vintage years. So we have to do this for all these technologies. And as you can see here, as I said, it says what you need to put in each parameter. For example, here you need to put, for example, you have the parameter, and you have to put the node and the year. So it's very easy to follow. Here they put this just to see what the function df does. So let's run to see. So what's the, you can do this for any other parameter. So here is a show what the make df does. Extend or overwrite base with new values from Quargart. So here we have parameters and returns and some example. Base equal to make df base. So just to show how friendly it is, you can go here or you can just use this to find the information from each parameter. So then we have the base output. As the same, we are saying to have to keep this definition, and then add in parts the grid and the bulb, the scenario, and all the others information we are adding to this model. We have to make from scratch all the Austrian electricity energy system. So they are really including everything. You could do this for Brazil just using this and change the parameter, the numbers of the parameters. So it's a very complete model. Okay. So then base technical lifetime. Here they put the lifetime for the coal power plant 40 years, 30 years for gas, 30 years for oil, and 60 years for hydro, 20 for wind, and 20 for solar. 1 year for the lamps, bulbs. I think it's incandescent, Julia. I think this is, and this is fluorescent. Okay. Here is very important, which is the capacity factors. For the coal power plant, is 85%. The hydro is 0.5, winds are 0.2, and solar 50%. These are for the lamps. And then the technical economic parameters. The is in dollars per kilowatt. And here we are adding a unit, but when you run, you're going to say that we already have it. And here are the costs for each power plant. So these are open. You can change when you're making your own model, or in the case of Brazil, or a region you want to make. And then the fixed cost in dollar per kilowatt per year. So every year a fixed quantity is destinated to cover part of the operation and maintenance costs based on the size of the plant. For example, lighting, labor, schedule maintenance, and etc. These are the costs they applied for these power plants. And then they also put the base variable costs. The variable operation and maintenance costs are associated with the degradation of equipment when the plant is functioning per unit of energy produced. So if you're not producing, you're not generate the variable costs. And okay, this is just how it works. Here are the variable costs they applied for this Austria model. These are the dynamic behavior parameters. We're just gonna through this. Here is the base activity and the in gigawatt hours from the IEA electricity output. So just gonna run base capacity, base activity, and finally the emissions. Here you are adding the carbon dioxide and the greenhouse gases emissions. Okay, so now let's solve our model. So we just have to solve. And then this is the primary response, which is the optimization of the model. This is the objective, is to optimize the portfolio that are going to attain the demand of the Austria demand. Now you're going to plot the results to see how they optimize this value and which are the power plants they were chosen and for the years to come here. So you have in 2010 mostly hydropower plants to attend the demand. So this is the new capacity for the Austria power plant. For 2040, you're going to add gas power plants and also coal power plants. And then this is the new capacity for the lamps. This is for the incandescent lamps, and none is necessary for the fluorescent lamps. And then the Austria energy system capacity to attend the demand in gigawatts. So we can see that the wind, it's losing a little bit along the years, and the hydro is increasing with the gas power plants and also with the coal power plant. So this is also for the lamps, which is the objective of this model, to check the power, the final use of the lamps. And then here is the energy system prices. So everybody managed to plot the graphics. You have any trouble during the tutorial to run something in the Python? Is everything fine? Okay. So the next step, after we have this baseline model, which is the complete model from Austria, we can run the other scenarios that we can create, and you can make it. So here you can keep going and load the other scenario. Now it's much concise. So you just have to change what you want to change in the scenario and check the difference from the baseline scenario. So here in this notebook, we load the previous build model of the Austria energy system to do some further analysis. The aim of this tutorial is to illustrate the workflow for subsequent analysis after the initial model development. So you can run a baseline model and then keep adding another scenarios without changing the other model. But before, very important, we have to close it here, so it's not going to work. Okay. Now let's load the other scenario. So the first thing as the other, we have to set up the packets. It's the same. And then name our scenarios. Here we are calling our baseline model we just created. Here is how it's gonna work. We don't have to run all the model that we just did. We just have to call it. It takes some time. It's very easy, friendly use. Okay, I'm done here. So let's launch the IX framework. I think they really did good work to put this model in the Python, so it's making much more flexible. So here we are already solving the model that we just called the Austria, and now we are going to plotting the results, but with another analysis. Here we're going to print the technologies. Here is the new capacity technologies. Here is the same as we see earlier. Let's see here. Okay. I think here is the same results. I don't see any difference. They're just plotting again. Okay, now. Okay, is the demand to attend the energy that's going to be necessary to attend the demands of the lamps, the total energy. And here we can see also the values, not just the, as we did here, just the graphics. Here they're showing also the values. Okay. It's the same results, just they add this information. Okay, so now we can close again and run the next tutorial. So let's see. The Austria multiple policies answers. So this is also really interesting from message that you can check if you're going to make like some policy to reduce the carbon dioxide emissions, to reduce the climate change impacts, and you can use message to do that. Actually, message was used by the IPCC to make the scenario, the RCP 8.5 was made with a message. Okay, so this tutorial is a part 4, investigation many policy scenarios. So this notebook contains the answers to the exercise in Austria multi-policies, which aims to investigate a number of different scenarios. The prerequisites we already have, that is the Austria and the Austria single policy that we just run. And this has been streamlined with a new helper functions, which is the make scenario that provides a scenario in which to develop a new scenario, and read scenario that provides a scenario used for investigating results. And these functions are used as follows. With function, here we have the arguments, SDS, do things with the data structure. All of the opening, closing, running, and committing actions are handled for you. Your job is to concentrate and identifying and updating the scenario variables and then investigating the results. You can, of course, get the scenario as you have worked on previous as well. So setup and help variables is just as the same that was already done. You don't have any questions, nothing, you don't want to show your Jupyter, you want to say, yes, I made it. No? Okay. Because in the first time I did this, it wasn't working, the graphics for me. It was not showing here. So I need to make some adjustments in my computer. So we are launching the IX framework or platform. We are still in Austria. The range is still 10 years from 2010 up to 2041. We have the same power plants. Here is important to notice that you can add power plants, you can add other kinds of lights, you can add storage for Renault, for example, that's working with KAIS. You can add here this technology and test it. You just have to make sure you are adding out the node, it's not nodes, but the parameters needed, like investment cost, variable cost, technology, the time, lifetime. I'm just preparing you for Bernan. Bernan is going to hit you a little harder, I think. So here we are going to test the wind subsidies. So we run the wind subsidy scenario using this framework. So these are subsidies for wind sources, wind power plants. So the value is 1,100, and we're multiplying for the subsidies. This is the policy scenario we are working on. Let's see how it's gonna work if you have subsidies for wind sources. And then we're gonna read scenario and a scenario as base, and then we're gonna plot new capacity. It takes some time. And then we are going to work with the demand-side learning. And this model does not use CFL. Oh, here are the results. Okay. So these are the new capacity. Oh, here you can see the difference with the subsidies. We can see wind power plants. let's see how it was before the new capacity, if it was the same. It was around 2 gigawatts, I think. No, it's still the same. Oh, I think it's the same. Okay. And then here they are making another scenario, which is for the CFL. So in this baseline, because they are too expensive. So what happens if their cost reduces with time for these kind of lamps? So they're creating here some range of costs. And then they're going to add 900 and multiply by the costs. And these costs are decreasing along the years. And then let's see how it's going to place this scenario with a decreasing cost for CFL lamps. Before Python, the message was it have a framework, like a software, like a normal software, when you just put the parameters. But I think you can download the old version, I think. But it's not updated. But you can see how it was. But I think this can be a little more work to set the parameters, but it's more flexible. Let's see the results. And with these tutorials, you can make your own scenarios. Okay, these are the results. Now you're going to check, this is the old scenario, now we're going to check the new scenario. And let's see the difference. Over here was the new scenario with base scenario, okay. Yes, I don't know. I'm facing the same problem that Fernando is facing. Fernando is a student from UFRJ that's working with Python too, with the message in Python. And he's facing this problem that the new scenarios are the same, has the same results at the baseline scenario. So I'm experiencing the same problem. I don't know if it's a problem or maybe it's just the tutorials.
Just a suggestion, Natalia. I'm here. Yeah, I'm facing the same trouble that Natalia is facing now. I believe that I'm seeing that you are running multiple answers, but I believe that we didn't run a single policy scenario.
Which
first.
Oh, okay. We have to do that. I thought we did it. Okay, thank you. I didn't know you were there. So nice. And
But
then I was like,
the problem that I'm facing with.
Yes. Okay, so let's start again. So let's close this. Where is the closing? Close. Then they have some exercise. Okay. I don't know where to close. Let me do that here. Yeah. Yes, we can do that. We can do as Julian is saying, but I don't know if I can create from scratch. So we can do something like, I don't know, Julian, what to think, but we can duplicate the Ultra model. I'm gonna here you have a copy. Now we are gonna change the prices, and then we're gonna check the Ultra results with, we are gonna change as Julian said here, and to see if the model is changing. The results are. So let's run this very quickly, just changing some values. Just gonna take a little bit to run again. You can do the same as I'm doing right here. You just have to copy. Here you just select and duplicate. It's very simple. So let's start thinking what we're gonna change. Okay, so I think we're gonna change the cost of the power plant. No, Julian, I think it's better. Let's make a power plant very cheap. Let's see. Here's the lifetime, capacity factor. Here, the costs. Let's change here. Let's make 4. Okay. Sorry. 1? No. 2? Okay. Okay, let's change this. Yes. So here is the optimized result. Let's see if it's gonna change. Yeah, it's changed a little bit. Let's see the graphics. So the new capacity is still the same. Oh, here it changed. The CFL, it's present here. Let's check with here. The new capacity. It's look like the same. No, here we have solar. It's a very small, but you can see like a little green over there. So it worked to put the solar power really cheap. And here also, they are not set up here. I think it's a default in this case. Okay, but we can change that. Okay. So let's see if change. Fernando, it changed for you? No?
For me, the problem was different because when I run another, how can I say, another case, when they put in the same plot area the two cases, the response was the same. That was my big problem in the single policy archive.
Okay, in the single policy. Here, I think it's the tree now. Yeah, the policy
Yes.
scenario. So I didn't understand. Sorry, Fernando. What?
The problem when you go to the part when you plot the results, you have two plots. The plots of Austria base case and the plot of Austria single policy. They were the same for me. If you run this code, you will see two different graphs. I saw two equal graphs. That was my problem here.
Okay. Okay, I'm gonna run this again. Let me close this, and then we're gonna through yours. So let me close this, and let's run the one policy scenario. So this is the one policy scenario. We are already running with a lot with more than one policy scenario. I skipped this. So sorry. So let's run this and see if we have the same problem as Fernando. And this is also a very nice way to learn Python. If you're not familiar with the language, because all the tutorials are very explanatory and it's easy to use. Okay, almost there. Now create the new policy scenario data structure. So this operation is done by cloning the baseline scenario, which will then be edited. So the model is the Austria-based model. Here are the details. Horizon. And, edit the data structure with the scenario parameters. Introduce subsidies that decay with time. Initially, they are 50% of the total investment costs and decay to 0. So they start with 50% and decay to 0. So they already did that for us. Here are the investment costs. So we add the subsidies. Now you're going to solve the model. So here is the results. Let's see. So we have the results for country. So these are the same results that we did with the baseline scenario. Let's see. Okay, base plots, politic base year, subset plants. So we are comparing this with the Austria model, and it's the same, Fernando. It's what you notice.
For me, it's the same, but I believe that in your case you will reach the same result because you are running your model with that values that Julian just told before, like 2 for CFL and 4 to solar.
No, because I changed that in the copy, Austria copy, and here I use the Austria model. I didn't change in the Austria model.
But when if you can down a little bit there, you can see that Austria, that little table, is telling us that the values that we see here.
Where here? Where, Fernando? Sorry, I didn't.
This line that you were seeing now, when you see the Austria bulb, CFL, and values, you see that 2 that Julian already told.
Okay. Yes, you're right.
I believe that the problem is that you copied the Austria baseline scenario, and when you run it, it's like they saved that run over that first run because the name was the same. Just a guess, but I don't know.
Yeah. I thought that cloning and make like Austria copy, it would have changed it, but as we can see, it did not. So probably because here, how does the copy? Probably have to change here too. When you call,
I believe that you
You're
have
right.
to change send to baseline to a new model, something like that.
Yes, you're right. Okay, yeah. So it's gonna be different than before. So I didn't help you, Fernando. Sorry. I tried.
No problem.
But it was a really nice to test and show how can be used. So now we learn again that we have to change these parameters too.
Yes.
Okay, so Julian, I don't know if you wanted me to run another models, another tutorials. You wanted to. Here we have more Westeros. On my thesis. So yes, I'm gonna share the link. So I'm opening here the. No, I'm just starting. Julian is lying. Okay, here is the link in the. So tomorrow at 1 p.m. you can access this link to watch the presentation. I'm going to present how the climate change will affect the renewable energy generation. So in my thesis, I would change like some parameters that over there and check how the scenarios are going to change. For example, the capacity factor or investment, the cost, no, but other technological parameters, storage. And Fernando, you're going to, Fernando is over there? Yeah. Fernando, you're going to work with pump storage in your master?
Yes, pumped storage and maybe storage capacity with batteries.
Oh, nice. Renan, you are working with KAIS in your masters? You're not planning to use message to run some scenarios? Okay, Renan is not.
I can try. It's not so simple as I can see.
I just give you some work to thought. Okay, so I think that's it, Julian. So thank you for inviting me. I hope I helped you. Okay, thank you. See you. Bye bye.
Thank you.
Thank you.
Tchau,
Bye.
até mais. Boa sorte amanhã no time.
Obrigada, Rodrigo. Vai assistir, né?
Claro, não vou perder, né?